Alright, so here's 6.5, finding real roots of polynomial equations. And we're going to identify the multiplicity of roots, and we're going to use the irrational root theorem and irrational root theorem to solve polynomial equations. But first off, before you do that, you have to look at the different ways you can solve polynomial equations. Keep in mind that roots, zeros, and solutions, they're all the same thing. So if I'm saying find the roots, the same as like finding the zeros, which remember, we use the zeros for graphing, or finding the solutions, so keep that in mind. So the next part would be use, I think here, sorry, I think I meant to put here you can find solutions by different means, not use solutions by different means. So, oops, my bad. So I'm kind of reading this, I'm seeing this, and I'm making mistakes, but we'll go with that. So let's look at this. You can find solutions by different means, and we can do this first by factoring. So let's look at one with factoring. 3x to the 5th plus 18x to the 4th plus 27x cubed set equal to 0. So here you go, looking at this, you go, first off, are there any common factors? Because this looks like something we've never really seen before. Well, common factor, you should see that there's at least 3 x's they have an x cubed. All three of them have an x cubed in common, and they're divisible by 3. So we can factor out a 3x to the third power. When we do that, that would leave me with x squared plus 6x plus 9. Then you can factor the x squared plus 6x plus 9 to be x plus 3. Notice I still have the 3x cubed. So again, this comes back to your factoring rules from chapter 5 last semester. So you have to go back to those, like saying a plus plus is a plus plus. 3 times 3 is 9, 3 plus 3 is 6. Okay, set them equal to 0, everything. 3x to the third power equal to 0, x plus 3 equal to 0. And you'll get x is equal to 0 and x is equal to negative 3. Now we'll discuss what it means that the fact that it was x to the third power was equal to 0. That tells you just how many times that was equal to 0. And that the x plus 3 happened twice. But that will be something we can work on later. So let's go to this one, x to the 4th minus 13x squared plus 36. I can factor that, thinking of that like as an x squared. When I split up x to the 4th, you're dividing it into equal halves. So you have x squared, and then a minus plus is a minus minus, and 4 times 9 will give me 36. 4 plus 9 gives me 13. So again, going back to those factor rules, just a little bit different than what we've seen before. Then you have to recognize that the x squared minus 9 and the x squared minus 4 are both differences of 2 squares. So I can factor that to be x plus 3, x minus 3, x plus 2, x minus 2. Set each one of those parentheses equal to 0, and I would basically get the opposites. So I would get x is equal to negative 3, positive 3, negative 2, and 2. And here I'm showing you a graph. I graphed this on my Inspire, and then from there you can see here, look where they're crossing at the x-axis. That one right there is your negative 3. The next line, that's my negative 2. Then the other one is positive 2, and there's my positive 3. So that is, you can use the factoring, or you could even do graphing to find the roots, especially the real rational roots. Okay, so some answers can occur more than once. Those answers create multiple roots. So when we do multiple roots, what we call that is multiplicity. How many times did it happen? So here's an example that you're seeing here that I just drew. Okay, when you see it like curve like that turn, we call that a turn. When you see it turn at a point, then we're saying that it must have a multiplicity of 2 or more, but usually 2. When you see it curve or bend, like the other example, the other one that's crossing the x-axis, that means it has to have a multiplicity of 3 or higher, but we'll probably be with 3. I don't think I'd be much more cruel than that. So again, we're going to go with when it turns, it's got a multiplicity of 2. When it bends, it has a multiplicity of 3. Okay, so let's identify the real roots and state the multiplicity.
Can I finish my text?
Okay, so here I'm looking at again identifying the roots and state the multiplicity of x cubed minus 9x, that should be a squared, plus 27x minus 27. Okay, so I graphed this, and you can kind of see here. You can kind of see here that it looks like it's crossing at right that point right there, which looks to be at 3, because I'm counting and I can see that my scale is 1. So I changed that to, so I believe that would be a 3. So I'm going to say x could be equal to 3. It looks like it's pretty obvious right there. Now, because it bent or it curved, that means that that 3 happened 3 times. So that means that the answer was 3 with a multiplicity of 3. Now, think about this. We have an exponent of 3, that's my degree, and I am saying that that 3 happened 3 times. So how many roots do I have? 3. Because this 3 happened 3 times, and that matches with the exponent. Always keep that in mind. Whatever your degree is, that's how many answers you should have. Okay, here's another example. Negative 2x cubed minus 12x squared plus 30x plus 200. I graphed this one. I did change the window settings, and if you want to know how to change the window settings, check with me the next time. But basically I went to the menu, I went to window settings, and then I changed the x max and x min there. And you can see here my x max or x min is negative 8, my x max is 8. Y min is negative 50, Y max is 250, and then I just let it do auto. Keep in mind here that this one they changed the scale to 0.5, so each of these little marks represents a half. So I can see here that this is where it crosses and it's curving, or it's turning, I'm sorry, it's turning. So that means that number right there has a multiplicity of 2. Now, counting that as halves, that actually ends up being 5. Because if you count it as 10 marks, half of 10 is 5. So that's right there is actually happening at 5. Okay, so that means, and again, it has a multiplicity of 2. The other one just goes straight. It doesn't bend, it doesn't change or whatever. And so if you count that, that should be like 8, and 8 divided by 2 is 4. So that tells you that crosses at 4. So, and that one only has a multiplicity of 1. So 2 and 1 equals 3. Keep that in mind. That's how many roots I had. Okay, so now we need to know what's the rational root theorem. You can look on page 439 at the bottom, and it tells you what the rational root theorem is. Essentially, the rational root theorem is like you're creating your own multiple choice bank that you can use to help you figure out what roots might work. So with synthetic division and graphing, we usually can find those. Now, what it basically comes down to is this. You look at the last number, 50, okay, that's your, what they say is P, okay, and you're finding all your factors of 50, and you're saying plus and minus 50. So plus and minus 1, because it's always divisible by 1, all the numbers that can divide into 50 evenly. So 1 and 50, 2 and 25, 5 and 10. All those numbers divide into 50. Then you find Q. Q is the number that's in front, the leading coefficient. So that's 1. plus and minus 1. Then the rational root theorem says if you take all the p's and all the q's and divide them, those are the possible answers you could have. So here I have plus and minus 1, 2, 5, 10, and 50. I'm sorry, and 25, and then 50. So we've got those. Those are all my possible answers. Remember, it's plus 1, or positive 1 and negative 1. Positive 2 and negative 2. Positive 5 and negative 5, like that. Now, I will recommend going ahead and graphing the problem. Okay, so here's where I graphed it. I did change my settings a bit to see it a little bit better. You can see my x-min is negative 6, my x-max is 6, my y-min is negative 50, my y-max is 50, and I believe my scale there should be 1 for my x's, because I wanted to make sure you could see that where they cross. So if I look at that, it looks like the graph crosses the x-axis at negative 5, positive 2, and positive 5. Using synthetic division, I can check to see if those answers are correct. So I have the negative 5. I'm going to try that one first. And again, I want a remainder of 0. So I put in the original polynomial, go through my synthetic division, and I get a remainder of 0. So negative 5 is an answer. Then I'm going to continue from there. I don't even go back to the original. I continue from there with 2. So that one will work. Okay, so that one works. Then I could say if this was x cubed, this is x squared, this is x. So I have x minus 5 is equal to 0, and I could quickly solve and say x is 5. So all three answers checked out. That allows me to check, using the calculator, I can get my possible answers and then check with, say, synthetic division. Why am I going to make you check? Because sometimes those numbers may not exactly work the way you want them to. And here's the reason why I want you to check, always check them. Because we also have the irrational root theorem. On page 441 at the top of the page, it gives you some long definition, but basically it says this. If you have an answer that comes out like as a radical, a plus b squared root of c, then if that's a root, then a minus b plus the square root of c, this should be a c, is also a root. So keep that in mind there, that if a plus b square root of c is a root, so is a minus b. They always occur in conjugate pairs. So if you have a plus square root of, or a positive square root of 5, you also have a negative square root of 5. So for another example, we're going to identify all the roots of 4x to the fourth minus 21x cubed plus 18x squared plus 19x minus 6. Again, starting off with your p here is 6. So we're going to find all the factors of 6, which are plus and minus 1, 2, 3, and 6. Q is 4. All the factors of 4 are 1, 2, and 4. Now, keep in mind here, what you're going to do is you're going to divide all the p's by all the q's. So the first one is all of those 1, 2, 3, and 6 divided by 1, which will just give us plus and minus 1, 2, 3, and 6. Then we're going to say, divide them all by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1. I've already got that. I don't need to write it again. 3 divided by 2 is 3/2. 6 divided by 2 is 3, which I've already got. Again, don't need it again. Then I'm going to do it again, dividing all of them by 4. So 1 divided by 4 is 1/4. 2 divided by 4 is 1/2, which I've already got. 3 divided by 4 is 3/4. And 6 divided by 4 is 3/2, which I've already got. So all these are my possible answers that I could have for finding the roots of that quadratic equation. Or I'm sorry, that quartic equation. So what I'm going to do is, again, do the graph. And you can see here, it looks like there's a couple of points. I got 1, 2, 3, 4 points where it could be crossing. One of them, it looks like it happens at 2. The other one, it looks like it happens at 1/2 or 1/4. I'm not quite sure. And then a third one, I can tell, looks like it's crossing at -3/4 because it's close to 1. So that one I would think is -3/4. The last one over there, it looks like it's crossing between 3 and 4. And none of my answers have something that crosses between 3 and 4. So that will come to later. That means we're going to have a irrational root. So I'm going to go ahead and try this with number 2 first and go through my synthetic division to double check to make sure that 2 worked. Okay, and if I go through the synthetic division, you can see here how I'm doing all the multiplying and adding, subtracting, and it comes out to 0. So one of my answers is x equals 2. Then continuing from there, I'm not going to go back to the top, I'm going to continue from there. So now I'm working with an x cubed, and I'm going to try negative 3/4. So I tried negative 3/4 because that one looked like it was pretty obvious. I get these numbers, and again I'm multiplying to get those answers, and I get a 0. So one of my other answers is negative 3/4. Okay, keep in mind that I have 2 rational roots, and if I have irrationals, they have to occur in pairs. Well, I'll go ahead and try the 1/2. I tried the 1/2. It doesn't work. I get some answer that it's not going to be 0, so that doesn't work. I'll go ahead and try 1/4. So I'm going to erase and then try 1/4. 1/4 doesn't work. So that tells me right there that those are irrational roots, like what's left here. So what I'm going to have to do is think of this as 4x squared minus 16x plus 4, because if I start out x to the 4th, then I went down to x cubed, then I went down to x squared. Could do quadratic formula, which you'd have to review and go back and be able to do. Plug in my numbers where they belong. And once I've done with quadratic formula, I would need to simplify. So this is not one where I want the decimal answer, I want the simplified answer. And if we do that, we'll end up with, see here, going through some of the work, you will end up with 2 plus or minus the square root of 3. 2 plus the square root of 3 is one answer, 2 minus the square root of 3 is another answer. If you did that as a decimal, you get 2 plus 1.7, which is about 3.7, so that would be the one that we saw on the right. And the 2 minus 1.7 would have been about 0.3, so that's the one that we thought was close to 1/2. So there's your 4 answers, 1, 2, 3, and 4, and that's how we get those. Here I have another example, 2x cubed minus 3x squared plus, I can't read that, minus 10x minus 4. All I did was I went ahead and did my p's based on the 4, plus and minus 1, 2, and 4, my q's based on the 2, plus and minus 1 and 2. Divide them, I've got plus and minus 1, 2, 4, and 1/2. That's it. Okay, look at my graph. I see 3 points because again, look, it's x cubed, so that means I could have 3 real roots. 3 points, and it looks like one of them is at negative 1/2. Another one's at, and the other ones end up at points I can't recognize. Because if you look, 1, 2, 3, like this one on the right hand side is like at negative or at 3.2. I don't have that as a possible choice. This one right here, it looks like it's at 1.4. Again, I don't have that as a choice. So the only one I can probably work with is this negative 1/2. And then the rest would have to be some type of irrational roots. So I go through my synthetic division, and negative 1/2 does work. Okay. Then this becomes this is 2x squared minus 4x minus 8. So my A, B, C, go through your quadratic formula. So I'm going through the quadratic formula, and it basically is, just plug it in, simplify, which you'll see me do. 4 squared is 16. I basically did the whole 4 squared minus 4 times 2 times negative 8. Now I'm simplifying the 80, taking out my pairs. So I have 4 plus and minus 2 times 2 is 4, square root of 5 over 4. All the 4's divide out, so my final answer there is 1 plus or minus square root of 5. So my answer was x is equal to negative 1/2, 1 plus square root of 5, 1 minus square root of 5. 3 answers. It was an x cubed function, so there you go. That is the 6.5 in a nutshell. I will not be there Monday. Mr. Valverde is a former math teacher, and he's our retired math teacher, so he can definitely probably help you. You will have your assignment. please work on it diligently. This is one of those, the more you practice with it, the easier it gets, because you will do this more than this one section. You will do more of this in other sections. So you need to make sure you practice this to get it kind of down. All right? Thank you very much.